Hello everyone. Today we are going to derive the formula for binomial pricing model single step. In last session we have discussed about how to calculate the value of a European call option using binomial option pricing model. Today we are going to generalize the formula that we had determined in the last session. Starting off with on the similar line, in last session we had created a portfolio by taking long position on delta number of shares at a price of S0 and taking short position on one European call option with a strike price of K. Here we have considered the interest rate to be R and the time step is equal to 1. As the time step is 1, so we can see that there is only a single time step over here. That is, the price of stock will be either increasing to S0U or S0D. The price will be moving upward or downward, that is S0U or S0D. Here we have taken short position on one European call option and the value of that European option we have assumed to be F, and in future the value of the option is considered to be either FU or FD. As we know, the call option is exercised when the spot market price on the date of maturity is greater than the strike price. Here the strike price is K and we have considered that on the date of maturity the spot market price of the share will be ST. Therefore the payoff of a call option will be calculated by subtracting K from ST. Hence, the value of Fu will be either maximum of St minus K or 0. This is so because the call option holder is having the right but not the obligation. Therefore, if the price of the stock on the date of maturity is less than K, the call option will not be exercised. Hence, the value of the call option will be 0. On the same line, the value of FD will also be equal to maximum of St minus K or 0. As we know that we have created a riskless portfolio by buying delta number of share and taking short position on one European call option. Therefore, as it is risk free, the future value of the portfolio will be equal for any change in the price. The future value of the portfolio when the price moves upward will be equal to S0U delta minus FU. As we have purchased delta number of shares, therefore the value of the share that we had purchased will be equal to S0U delta, and we have taken short position on one European call option, therefore it must be equal to FU. Since we have taken short position, therefore any value for any change in the value of the option, it would be subtracted from our portfolio's worth. So on the similar line, the value of SD when the price of the spot market price is equal to S0D, the value of the portfolio will be equal to S0D delta minus FD. And as it is riskless portfolio, therefore this relationship must hold true. On simplifying for delta, we will get delta is equal to Fu minus Fd upon S0U minus S0D. This is termed as the hedge ratio. We must remember this formula, that is delta is known as the hedge ratio, and on simplifying this relationship, that is S0U delta minus Fu equal to S0D delta minus Fd, on simplifying we will get delta equal to Fu minus Fd upon S0U minus S0D. The future value of the portfolio will be equal to S0U delta minus Fu, as we have already calculated over here, that the future value is equal to this one when the price moves upward, and when the price moves downward it would be equal to this one. Now we are supposed to convert this future value into the present value at an interest rate of R, and if we will convert this into the present value, it would be equal to present value of the portfolio will be equal to S0 u delta minus fu multiplied by e raised to the power minus rt. As earlier we have considered that the interest rate is r and the time period is t. We had created a portfolio by buying delta number of shares and one short position on one European call option. So when we entered into the when we had created the portfolio, the value of the portfolio was equal to S0 delta minus f. And as in the previous case we have calculated the future value of the portfolio is equal to S0 u delta minus f u, and we have converted it into the present value by multiplying it to exponential raised to the power r into t. So this was the present value by discounting the future value into the present value. Now these two values must be equal, that is S0 u delta minus fu into exponential raised to the power rt must be equal to S0 delta minus f. Now simplifying for f, we will get f is equal to S0 delta minus S0 u delta exponential raised to the power minus rt plus fu exponential raised to the power minus rt. By further simplifying the above equation, we can write it as f is equal to S0 delta multiplied by within parenthesis 1 minus u exponential raised to the power rt minus rt plus fu exponential raised to the power minus rt. Now we have to plug in the value of delta that we have derived. So by plugging in the value of delta, we will get f is equal to S0 multiplied by fu minus fd upon S0 u minus S0 d multiplied by within parenthesis 1 minus u e raised to the power minus rt plus fu e raised to the power minus rt. Now by simplifying, we will get fu minus fd upon u minus d multiplied by 1 minus u exponential minus rt plus fu exponential raised to power minus rt. Now by further simplification, by removing the parenthesis and simplifying, we will get, now we are going to simplify the above equation. By removing the parenthesis, we can write fu minus ufu exponential raised to power minus rt minus fd minus minus plus ufd e raised to the power minus rt plus fu e raised to power minus rt whole divided by u minus d. Now we can further simplify by taking the LCM and considering the second part as well. So by further simplification, we can do fu minus ufu e raised to power minus rt minus fd plus ufd e raised to power minus rt plus ufu e raised to power minus rt minus dfu e raised to power minus rt and whole divided by u minus d. Now as we can see, ufu e raised to power minus rt is here, and here it is plus ufu e raised to power minus rt. So these two terms will get cancelled and we will be left with fu is here and as well as over here, that is fu minus d multiplied by fu e raised to power minus rt, and here we are having fd, so minus fd plus UFD e raised to power minus RT whole divided by U minus D. Now take common Fu and e raised to power minus RT. So we will be left with Fu e raised to power minus RT. So we will be left with exponential raised to the power. I will be doing it on the another page by simplifying and taking common by simplifying and taking common, we can write it as that F is equal to, we have taken common Fu and e raised to the power minus RT. So we are left with e raised to the power RT minus D upon U minus D. And doing the similar thing over here, we have taken common Fd exponential raised to the power minus RT. So we will be left with U minus exponential raised to the power RT upon U minus D. So this is in terms of binomial option pricing model. This is termed as P and this is termed as 1 minus P. If you will simplify or simply subtract this from 1, you will get this one. Therefore, we can write it as Fu P plus 1 minus P into Fd whole multiplied by exponential raised to the power minus RT. So this is the formula that we will be using for binomial option pricing model. I will write it over here, that is the value of a call option can be call or put option can be determined using the following formula, that is Fu P plus 1 minus P Fd whole multiplied by exponential raised to power minus RT. So this is the formula that we are going to use for binomial option pricing model. Here we must remember P is equal to exponential raised to the power RT minus D upon U minus D, and 1 minus P is equal to U minus exponential raised to the power RT divided by U minus D, where P is probability of upward movement and 1 minus P is the probability of downward movement. Now we will be doing a numerical for further clarification. Here I am taking help of John C. Hill and the 7th edition is there, Indian edition, and here I am considering the question number 9. Here it is given a stock price is currently rupees 70. It is known that at the end of 2 months it will be either rupees 60 or 80 if the risk-free interest rate is 15% per annum with continuous compounding. What is the value of a 6-month European call option with a strike price of rupees 68? So I feel we all of us are with the question, that is the spot market price is 70, time period is 2 months, and the upward price movement will be 80 rupees or the downward price movement will be 60 rupees, and the risk free interest rate is considered to be 15% per annum with continuous compounding, and we are considering a European call option with 6-month maturity period and strike price of rupees 68. So we will be drawing a binomial tree. In the question it is given that the spot price, that is S0, is rupees 70 and S0U is given rupees 80 and S0D is given rupees 60. We have considered a European call option, 6-month European call option, whose strike price is rupees 68. and the time period here it is given to be 2 months. First of all, we have to convert it into years, so it would be 1 upon 6 years, and the risk-free rate is given to be 15% per annum with continuous compounding, per annum with continuous compounding. So we have to draw the binomial tree. It would look like something this one, that 70 to 80 or 60, 70 to 80 to 60, and here we don't have the value of fu and fd, and as we have already discussed that p is the probability of upward movement and 1 minus p is the probability of downward movement. So we can write it on the branches as well, that is p and 1 minus p. Now as we know that it is a European call option, and the European call option is exercised when st is greater than k, and here st is given to be 80 and k is given 70 rupees, sorry 68 rupees. Therefore st minus k comes out to be 12 rupees, and out of 12 and 0 the maximum is 12, so here I will be taking the value of fu equal to 12. Similarly, in case of fd, st is 60 and k was 68 rupees, so if I will subtract 68 from 60 I will get minus 8, and out of minus 8 and 0 is maximum, so I will consider the value of fd equal to 0. Now first of all we have to calculate the value of p, and as we know the value of p can be calculated using the following formula, that is exponential raised to the power r multiplied by t minus d upon u minus d. Now in the question u and d is not given, but as we can see that s0u is equal to 80 and s0 is 70. So from this we can calculate the value of u. So u will be equal to 80 upon 70, that is 8 upon 7. Similarly, S0D is given 60 rupees and S0 is 70 rupees. Therefore, D will be equal to 60 upon 70. So D is equal to 6 upon 7. So we have calculated the value of U as well as D. Now we can plug in these two values in the equation of P and we can solve for the value of P. So just plugging in the values over here, P is equal to exponential raised to the power, R was given to be 15%. So convert it into decimal 0.15 multiplied by T was given 2 months and we have converted into number of years, so it is 1 upon 6, and D we have already calculated, that is 6 upon 7, and U we have calculated 7 upon 8 minus 6 upon U is 8 upon 7, pardon, 8 upon 7, and it is 6 upon 7. On simplifying the above equation, we get P equal to 0.5886, and we can simply calculate the value of 1 minus P, that is 1 minus P will be equal to 1 minus 0.5886, and on subtracting this we will get 0.4114. Now we are having the value of P as well as 1 minus P, and the value of a call option can be calculated using the following formula, that is F is equal to P into FU plus 1 minus P into FD whole multiplied by exponential raised to the power minus RT. Now we are having the value of P, FU, 1 minus P, FD, and R and T is already given to us. So by plugging in all the values into this equation, we can calculate the value of the option. P is 0.5886 and FU, as we have already calculated, is 12 rupees and FD is 0. So we will simply plug in over here 12 rupees plus 0.4114 multiplied by 0. close the bracket, multiplied by exponential raised to the power minus 0.15 into 1 upon 6, and on simplification we will get, by simplifying the equation we will get the value of 12 multiplied by 5886 will be equal to 7.0632, and this value will be equal to 0, and on simplifying exponential raised to the power 0.515 divided by 6 we will get 0.9753. On further simplification we will get the value equal to 6.88 rupees. So this is the value of the call option for the given question, that is the value of option will be equal to 6.88 rupees. Now in the next question we will be doing for options, put options. We are going to consider the same case, that is the spot market price is S0 equal to 70 rupees, and the upward movement will be S0U, that is 70 to 80, and the downward movement would be S0D equal to 60 rupees, and a strike price of 68 rupees, and the risk free interest rate is 15%, and time period is equal to 1 upon 6 years. So the binomial tree would be something like this one, that is 80, and here it would be 60, and here it would be 70. We have to calculate the value of f, and here we are having fu, and here we are having fd, and onto this branch it would be p, and onto here it would be 1 minus p. Now this is the case of put option. And as we know, in case of put option, the put option gives the holder the right to buy, right to sell, but not the obligation to sell. Pardon for my mistake, it is the right to sell but not the obligation. So the put option holder will exercise the option only when K is greater than ST, that is ST is the maturity date price of the stock. So remember one thing, that the payoff of put option holder is equal to K minus ST, and similarly as we have done in case of call option, the value of put option can be calculated as maximum of K minus ST or 0, and similarly here, that is K minus ST or 0. As we know, here it is given 68 rupees is the strike price of the put option, and here the future price is 80 rupees. So when we will subtract 80 from 68, we will get minus 12 rupees. So out of minus 12 and 0, the maximum value is 0. So the value of FU will be equal to 0, and in this case where FD, when we will subtract 60 from 68, we will get 8 rupees. So maximum out of 0 and 8 is 8 rupees. So the value of FD will be 8 rupees. And now we have to calculate the value of P. As we know, the value of P can be calculated using the following formula: exponential raised to the power t minus d upon u minus d. And as we have done in the previous case, u was equal to 8 upon 7 and d was equal to 6 upon 7. So by plugging in these values, we will get exponential raised to the power 0.15 divided by 6 minus 6 upon 7 divided by 8 upon 7 minus 6 upon 7. On simplification, we will get 0.5886, and 1 minus p will be equal to 1 minus 0.5886. It would be equal to 0.4114. Pardon, it is 0.4114 Now we can calculate the value of the put option by using the following formula. The same formula we will be using, that is F is equal to P multiplied by Fu plus 1 minus P into Fd multiplied by exponential raised to the power minus RT. So we have calculated the value of P, it is 0.5886, and Fu we have calculated equal to 0, and 1 minus P we have calculated it is equal to 0.4114, multiplied by Fd we had calculated to be 8 rupees, so multiplied by 8, and exponential raised to the power minus 0.15 divided by 6. On simplification we will get it equal to 0 plus by multiplying 8 into 0.4114 we will get 3.2912, and exponential raised to the power 0.15 minus 0.15 divided by 6 we will get 0.9753. By multiplying 0.9753 to 3.2912 we will get 3.2099. So the value of put option, that is F, is equal to 3.2099.